Today we're looking at 3-1, pairs of lines and angles. Our essential question, what does it mean when two lines are parallel, intersecting, coincident, or skew? Coincident is not defined as we go through the notes. That's overlapping lines. Generally, it would be considered the same line. But if we're looking at them as overlapping, we would say they coincide or are coincident. Parallel lines. Two lines are parallel when they do not intersect and are coplanar, so they're in the same plane. Skew lines are two lines that do not intersect but are not coplanar. So parallel is familiar to most people. Skew is not. If we have a line here on the paper, right, and then I have the pen here that's above the paper, it's going in a different direction. There's no way I could connect that with a plane. Those lines are called skew because they have no real relationship, whereas parallel, there's relationships that we can deal with. Then parallel planes are two planes that do not intersect. Okay, and they have some statements here of lines that are parallel and perpendicular. Probably a little hard to see here. This says parallel lines M and N, and it has this symbol here. That is our symbol for parallel lines when we have two lines vertical next to each other. So looking at example 1. Example 1 says, think of each segment in the diagram as part of a line. Which line or planes contain point A and appear to fit the description? So the contained point A is important here. All right. They say lines parallel to CD. So CD is here. Okay. This line, and this line, GH, would all be parallel to that. But the only one that we're counting is the line through point A. So AB would then be our answer. Okay. Then lines skew to CD. So I'm still looking at this line. Okay. So lines that aren't going to intersect that, but you want them, again, it needs to be through A. So like EH would be skew to that. GF would be skew to that. BG would be skew to that. But the only one that is my answer would be AH. Actually, there is a line here. So technically, does it say which line or line? So AG would also be a line because there is a line here. It's hard to see. You could do other lines that aren't drawn on there. So like AE, AF, they would be lines that would also be skew. AF would come through the box. AE would come up this way. But they're not shown, so I don't need to worry about listing those, but I could include those. Lines perpendicular to CD, so that's hitting at 90-degree angles. So the only one through A would be AD. And then plane parallel, so they're changing it up here, EFG, which is the bottom. Okay, when I'm naming a plane, I only need to name it with 3. So EFG would include H. It's that bottom plane there. We just don't need all 4 letters. So the only plane parallel to that is the top. So we'll say plane ABC. Okay, but again, you could use D in place of one of those letters. So we're looking at angles and transversals. So a transversal is a line that intersects 2 or more coplanar lines at different points. Okay, and this is our typical example. What we're doing in this section is identifying them. Okay, so these exist whether the lines are parallel or not. As we move forward, we're going to look at rules for them. The rules only work if the lines are parallel, but the angles exist no matter what. Okay, and instead of writing this all out, I'm going to move in a sheet where I have it written out already. So we have 4 different types of angles. Our first are corresponding angles. They have corresponding position. So like 1 and 5, 2 and 6, 4 and 8, 3 and 7. All of those are corresponding angles. So and a lot of times you can look at these as where is this? So like angle 1 is below the transversal and to the left of the line. Angle 5 is also below and to the left. Okay. If you put a box around these, you have 2 different things here where you have squares. You could also think of that as a table. You could also think of it as the same spot on a different table. Then our second thing, we have alternate interior angles. Okay, these lie between the transversal, that's the interior, and on opposite sides of the transversal. So 4 and 6, 3 and 5. So those are my alternate interior. Alternate exterior, do the same thing, but on the outside. So lie outside the 2 lines and on opposite sides of the transversal. So 2 and 8 and 1 and 7 are my alternate exterior. And then consecutive interior, sometimes you also hear these as same side interior, which I actually like better. I think it's a better description. They're on the same side of the transversal and in between the 2 lines, again, because they're interior. So 4 and 5 would be consecutive interior, 3 and 6 would be consecutive interior. So then flipping over, so we have 2 postulates there at the top. They're written out for us. Parallel postulate and perpendicular postulate. They say similar things. One is just about a parallel line. One is about a perpendicular line. So parallel postulate says if there's a line and a point not on the line, then there's exactly one line through that point parallel to the given line. So we have the line L here and point P. So if this line is parallel, then that's the only line parallel to that line through that point. Okay. And if I'm marking these as parallel, you can sort of see it here. If you put arrows on them and have the same number of arrows there, that would be showing that our lines are parallel. Perpendicular postulate, again, similar, just perpendicular. So if there's a line and a point not on the line, so we have line L and point P, there's exactly one line through the point perpendicular to the given line. So since I know this line hits at 90, if I draw another line down this way, I know that line doesn't hit at 90 because it goes through the point. And example 2 asks us to name a pair of parallel lines. So I have the arrows here on these 2. So AB is parallel to CD. Then name a pair of perpendicular lines. So I have the 90 degrees here. Right. So I have AB perpendicular to AC. Okay. Then they say, is AB perpendicular to BC? My answer there would be no. And I know that because of the perpendicular postulate. AC is perpendicular to AB, so CB can't be. Okay. And then it says, is AB parallel to CD? Yes, that's what we said here. All right, AB and CD are parallel. Then example 3 asks us to identify all pairs of the given angles. So corresponding, okay. If I start looking at angles, angle 1, what's that match up with? That matches up with 5. They're both above and to the left. Okay. If I look at angle 2, that's above and to the right, matches with angle 6. Okay. Angle 3 matches with angle 7, and angle 4 matches with angle 8. Okay, so there are corresponding angles. The numbers are just identifying the angles, so I think these numbers match with what was on the other picture. That doesn't necessarily have to be the case. Sometimes you'll see them numbered 1, 2, 3, 4, 5, 6, 7, 8, right, which would change things, or 1, 2, 3, 4, 5, 6, 7, 8 would change things. So don't memorize the numbers, think about where they are. Alternate interior, so I want something that's inside and then on opposite sides. So pick one that's inside. 4 is inside. What's on the opposite side of that would be 5. So angle 4 and angle 5. 2 is inside. That's opposite 7. And then I don't have anything else inside. So that's all my alternate interior. Alternate exterior, start with 8. 8 is on the outside. What's also outside and alternate with that is angle 1. And then if I do angle 3, that matches with angle 6. Consecutive interior, so again I'm on the inside. So we start with 4 again. What's consecutive interior with 4 is 7. They're on the same side. So 4 and 7. And then 2 and 5 would be my other pair. And then example 4, classify the angles pairs as corresponding alternate interior, alternate exterior, or consecutive interior. So 3 and 4, they're interior and they're on the same side. So those would be consecutive interior angles. 1 and 2, they're on the outside and they're on opposite sides, so they would be alternate exterior angles. Okay, and that is our lines and angles and the end of 3-1.